Hey everyone, Andrew here. In this video we're going to go over the basics of Eurorack. This isn't going to be an all-encompassing video, but I want this to be a good kind of starting point, a high-level overview of how everything works, so you can understand those concepts when we go into more in-depth topics, in the future. So yeah, this thing here is a Eurorack synthesizer. It's a form of modular synthesis. So what is that? Well, a normal synthesizer is just kind of pre-made. Everything is connected a certain way based on the company that built it. They already determined what they wanted and what the customer is going to buy, and you can't really change it too much. But this can be whatever you want. And in fact, this is just my little case. I change the modules in this every week, or sometimes more frequently than that, to make a system that is either fun, well tailored to the music, the song I'm currently working on, or something I just bought and I want to focus on. For example, I just got this thing. This is an oscillator, and I want to play with it. So instead of it being in my main rack, it's on this thing that's on my desk, so when I make music, I just fire it up and play with it. So anyways, the way these modules are sold, they're sold as these things, these individual units or modules, and they can be as big or small as the company decides. And like this thing, for example, is a filter and a delay and a bit crusher. That thing I showed you before, this behemoth, is an oscillator with a tube inside of it. This thing here is a tiny filter. And yeah, so you buy these modules to fit your needs. This is an oscillator. There's hundreds or thousands of them. This is a wave folder. There's probably dozens available. Filters, hundreds of these in the market. VCAs, they control the volume of things, basically. Probably hundreds or even thousands of different options for you to consider. So you can kind of choose. You can look up everything for each type of module you want and choose what you want to buy. And on top of that, if you're making a certain type of sound, you're going for a certain thing, that can dramatically determine what types of modules you get. For example, you might not need a reverb, which is what this is. You might not actually need an oscillator. Like some people make full racks of just like reverbs, delays, choruses, and they just run their guitars through it or audio from their computer through it. It's kind of up to you, and that's kind of the blessing and the curse of modular synthesizers and Eurorack, is that it's really up to you, so no one can tell you what's the best thing to get. So anyways, let's go through some general kind of high-level ideas. So the first, the most important thing, and I almost didn't even want to bring this up in this video, but because it gets kind of deep. When you buy these modules, they come like this. You need a case. So you have to buy a case, and then you have to buy modules. This case, for example, costs $300. Now, this module costs like $110. This doesn't make sound, so you can't really do anything with this. So that's kind of one thing to understand when you're getting into this, is this is typically much more expensive than just buying a synthesizer. So modules, they get plugged in, you screw them in here, and then you patch things from point to point. So I'll show you this thing. This thing here is an oscillator. I can grab the output of this oscillator and put it into this thing here, which is an oscilloscope. I'll tweak this a little bit. Here I'm outputting a sine wave. I can change how fast it goes. It can get so slow that you wouldn't be able to hear it anymore, or it can go so fast you probably wouldn't be able to hear it anymore. And that's probably actually why it starts shrinking here, is probably because this module can't process it so fast. But that's a signal. In this case, it's an audio signal. This thing is generating a sound, and you can do stuff with it. For example, I can just grab the output of this, and it's going to sound absolutely dreadful. Grab it and put it out to my computer here, recording the audio. If you had a dog in the room, they're probably turning their head and looking at you right now. But this is an oscillator. It makes sound. Now, if I slow this down enough, you can kind of hear it. But there's actually a switch on here where I can bring it even lower. I can hear it here, but if I go low enough, it's just a bunch of clicks. You don't hear it as an audio anymore. And that's kind of the first general concept I want to bring up about this stuff, is that there's a difference in modular between like signals that are carrying audio and signals that are controlling stuff. And signals that are controlling stuff are called control voltage. So one good example of control voltage is an envelope. And so an envelope is something that controls the contour of volume or whatever over time. So if I click this, oh, nope, I'm just stupid. There we go. See that? That's an envelope. Every time I press this button, I get a shape. So what can you do with that? Well, if I grab that oscillator that I had before, instead of patching it directly to the output, I'm going to put in this thing called a VCA. And then I'm going to grab the output of the VCA, go directly to the speakers. Cool. So now we get a sound. Now what I can do is I can patch the output, which in this case, this module, basically this input gets patched here. So I can just grab this, and it's the same thing as grabbing this signal. So again, this signal is passing over this wire now. So I can put this into this, and now when I turn this back up, we hear nothing. But if I press this button, the volume is being controlled by that signal. And instead of grabbing this envelope, this one is only blinking. You can kind of see it blinking, but that's because this one is shining into it. It really only blinks when I press the button. But these are just running on their own, and these are called Lfos, or low-frequency oscillators. If I control 2 instead of 1, I'm controlling the speed. If I can make it go fast. And if I keep going, it's going to get so fast that you hear another note. So this module is sending control voltage, which is just a signal that controls essentially this volume knob. Like I could sit there and just turn up the volume, but that doesn't make sense, especially when you might want to turn the volume and the filter and some parameter in here all at the same time. You can't do that by yourself, predictably, anyways. So that's where modules like this come into play. They make envelopes, they make LFOs, they make, there's hundreds of these types of modules that can essentially just turn knobs for you. And that's really what control voltage is. Something that changes a parameter for you automatically or when an event happens. So now let's grab the output of our oscillator, and I think you get this idea, right? So I'm going to take this out, and I'm going to patch this LFO straight into the VCA. But now, before I go into the VCA, I'm going to go into the... actually, I'm going to go into a filter, and then I'm going to go out of the filter into my scope. And then, bear with me 1 sec, you'll see what this means in a minute. I'm going to go out of this and go into the VCA. So, what I just did is I put a filter in the path. So if I turn this up, we're exactly where we just were. And I'm going to slow this down a little bit. So this volume change is happening after the scope. So right now we're just looking at the audio signal. I can change the time of this to be so fast that we see the actual waveform running. So this is the waveform running through. It's a sine wave. If you've ever taken, I guess, trigonometry, you've seen a sine wave. Or if you've ever played with a synthesizer, you've seen a sine wave. Now, this particular oscillator is very fancy. Don't worry about this. I can change to a saw wave or an inverse saw wave. I'll just do a saw wave. I can even make like weird shapes, and I think there's a way to do a square wave, but I don't quite remember something. Yeah, square wave. So this module just makes different shapes. So we're just going to do a saw wave here. So this is patched through a filter. So I don't know why this is jittering so much. That's fine. So a saw wave has all these little spikes on it, as you can see. And a filter essentially smooths out spikes. So I'll let you listen to this. It's very harsh. It can sound really cool, but it's really harsh. We change the scale here. Now the filter, this is a low-pass filter, so it lets low frequencies through and high frequencies pass. If you think about it, a high frequency is just something that happens quickly. And these jagged edges, well, since they're so sharp, that means they happen quickly, right? Intuitively, if something is really sharp, it has to change really quickly. So if a low-pass filter filters out high frequencies or things that happen really fast, it's going to smooth out those edges. And that's exactly what happens. And I'll let you hear it at the same time. Like now it just looks like a sine wave. And if I change to a sine wave, now in this case the sine wave's an octave lower, but they sound exactly the same. And that's just because I filtered the sharp edges of this so much that I turned it essentially into a sine wave, which is just a pure waveform that has one fundamental. I won't go into the details of that, but if you know what I mean, you know what I mean. So we have an oscillator making a sound, a filter filtering or transforming that sound, a VCA that allows an envelope, or in this case an LFO, to change the volume of it. And then we have this scope so we can just kind of peek into it and see what's actually happening. So overall, super important concepts are that audio can pass through these cables. We can process that audio with modules like filters or whatever, and we can control knobs with something like this. And in fact, just another example, we can grab a different LFO and control the filter. So here, now I'm using one LFO to change the filter and another one to change the volume, so I get this kind of syncopated pattern, and the sound just evolves on its own. Change that. So that's cool. Now, I'll explain another concept to you because I think this one's very important. This is probably the most boring one. But these envelopes just output, a shape of a certain size. So what I mean by that is, first let me just kind of clean this up a little bit. I'll just probably cut this out. There we go, we're clean again. So now I'm going to grab this LFO and put it in here, and then if I change the time, probably something like 2 seconds. We're going to see the signal going up and down. And this is a certain size. And in this case, it's probably, I don't know. So here you might not be able to see this. The signal is, the scale is 5 volts. So one grid point is basically 5 volts. I can make it 1 volt, and I can change the position to be minus 2.5 volts. And now we're seeing that it's basically 1, 2, 3, 4, 5 grid points high, so it's a 5 volt peak to peak signal from bottom to top. Now, depending on what module you have, 5 volts might turn the knob from here to here. It might be this kind of like halfway thing. Or 5 volts might turn it from here to here, basically the whole knob position. Every module has a different amount of voltage that will control how far it goes. And that's both a good thing and a bad thing. Sometimes it makes sense to have different ranges for things. So what if this is too aggressive? So if I output this and I send it into the filter, this might be, and I'll have to grab some audio here, output of the audio into the filter. output of the filter, we'll just go straight into the audio. And in this case, I think that's pretty good. But what if we don't want that? Well, there's this concept of an attenuverter or an attenuator. And so this module here is capable of doing attenuation, attenuverting. And I think it's easier just to see it, so I won't even try to explain it badly. I'll just show it to you. So instead of going directly into the scope, actually, let's do this. We're going to go directly into the scope. We're going to go out of this guy into our attenuverter module. We're going to go out of the attenuverter module into B, and then we're going to go out of B. I'm sorry, not B, 2 on the scope. We're going to go out of that, and then we're going to go into our filter. So I have to actually turn this on here, visualize, and I'm going to change some settings. I'm going to do the same. The 1 volt thing, position minus 2.5. Doesn't have to be perfect, but I want to get this kind of close. Minus 2.48. You can see what happens here. Right now, they're exactly the same. So this knob here, this is controlling A here. If I turn this down, now we have a slightly smaller signal, and you can hear what that does. Basically just allows me to make that modulation, that control voltage, a little bit more subtle. Like this thing outputs 5 volts peak to peak by default. Some modules do 10 volts peak to peak. Some will do whatever. Whatever the module does is what it does. But it can be very useful to be able to control that. Because this, in this case, it's a filter sweep, but it could be vibrato. It could be anything. You could be modulating whatever you want in the system. Basically, any of these knobs, a lot of these knobs, some of these knobs, some of these knobs, and all these knobs, pretty much, are things you could modulate with, with other parameters. So you don't always want full swing, and that's where this module comes into play. Now, in another case, you might want to flip it upside down. So let's just put this max. Right now it's the same. Now, the way this module works, instead of just being an attenuator, now I turned it into attenuverter, which is gonna, instead of just attenuating it or changing the volume, when I get to 0, I can go negative. And so now it's actually peaking in the negative direction, so I'll have to move this up here. And now we are controlling it in the negative direction. I can go back up here. And now I'm peaking in the positive. So this module here lets me control the depth of a signal, which could just be a volume control. I could patch an oscillator into this, and then I just have a volume knob. And that's why a lot of attenuverter modules like this one, you can actually just patch 4 different things in it and use it as like a little mixer. So that's a pretty common secondary use, but attenuating and attenuverting is sometimes useful. Sometimes you want to flip a signal upside down. Sometimes you want to just shrink it. And that's what happens here. And this is a super common thing. Now, I don't know if there's an example of a module on here. Wow, it's actually surprising. There we go, I found a good one. So this module is called Plonk. This makes crazy drum percussion sound and other pitched physical modeling instruments. Don't worry about it. But these knobs here, these are on a ton of Eurorack modules. And these are just little attenuverters. So what these do is, let's say you wanted to control the decay, and it might be a little out of focus. You wanted to control the decay of a parameter in this module. Well, you could just patch into here and control it, but instead of having to use a dedicated attenuverter module like this just has it built at all the inputs. So I could just put in that 5 volt signal directly into there, and then I could just shrink it. And then if I wanted to, I could keep going, and now I'm inverting it. So now I have a negative modulation on that parameter. And you'll see these in a lot of modules, especially mutable instrument stuff, and I think also make noise and pretty much every company has them for the most part. Some companies don't, like Noise Engineering, which makes this module, this module, this module, and this module. They don't really do them, which on one point, it saves a lot of space on the module. But that also means you have to have one of these modules handy. Otherwise, you're stuck with whatever signal you're generating. So it's kind of a preference, really. But I really love it when modules have built-in attenuverters when it makes sense to, and it's not sacrificing something else to have it. So now that I've kind of told you like the gist of how this stuff works, we can make sound, we can process the sound, control the volume, use control voltage to move stuff around. We also have like effects, which is just a reverb module, and it's really cool. And actually, I'll show it to you real quick, because I think these modules are, some people only use modules like this, because maybe you're just processing your like guitar, or maybe you're routing audio from your DAW into your system. A lot of people will actually just have a system of only like reverbs, delays, whatever. They won't even have oscillators. So this is a reverb. Just peaked a little bit there, so I got out of control. So like, this is a completely different thing. Here we're messing around with these signals and just making sounds, and this stuff is kind of like the bread and butter of most modular systems. But some people just do effects. I kind of do both. Some people make generative systems that you just literally turn them on and they make music on their own, and that's really cool. Other people use this to make synth sounds that they can record into their music, and that's kind of what I do a lot of. Sometimes I'll route audio from my computer through my main modular system, which you can't see here, and process it to make some cooler sounds. Other times I'll use this to replace something like Serum or Massive X, which I might have in my DAW, but I might want a more complicated sound, or just something that's more fun. Like this stuff can get really fun. So you get to design your system to your whim. So the last thing I want to talk about, and then we'll call this a video because we've been going for a bit, is this stuff is not cheap. And I kind of mentioned this before, but this system here, I don't know the exact cost if you were to buy this exact thing, but this case alone is $300. This module here, just this block here, is like $300. This thing's like $100, this thing's like $120, this thing's like $100, this is like $150, $150, $350, $350. This stuff's expensive. This thing here alone is like $2,000. So if you're trying to get into just getting a synthesizer and learn about the basics, this is not the way to do it. The best way would be something like VCV Rack or Soft Tube Modular. And I won't show those here. You can just look them up. I'll put some text in the description. Those will let you play around with the concept and ideas of modular in software so that you can actually see if the stuff's for you. Another idea is buy something that's semi-modular, like a Moog Mother 32, a Behringer Neutron. Both of those would be fantastic options. You get a used Behringer Neutron for probably $250, whereas this would be $2,000. Now, you don't have to buy all of this at once, but if you just buy this, you're just going to have an annoying oscillator. If you just buy this, you can't really do anything. It's a wave folder. Same with the filter and the VCA. Like, you can't just, there's kind of a minimum buy-in. You have to buy a case, and this is a small and affordable case, or you could build a case. But then you might have to buy this, and you might have to wait a couple weeks to have the money to buy these two things, and then you might need one of this. You might have to wait another week to buy that. So it's kind of an expensive long game. Try not to rush it. I certainly did. But yeah. Anyways, we're going to get more into this stuff in the future. If you enjoyed this video or you have any specific questions, leave me a comment. Hit the like button. And yeah, I'll see you in the next one. Bye.